Okay, so is it audible? All of you online? Hello? Yes, okay. Good. ત્રણમાંથી બે થઈ જાય. One bench two. Yeah, so we have 28 participants. Good morning to everyone. So wait for 1 or 2 minutes. So when everyone join, then we will start. Okay. Wait for a 1 or 2. Is the screen visible? Yes, અહીંયા તો દેખાય જ ને. Is it visible online? Okay. ચલિए. Start in few minutes. Okay. So let me just start with the basic stuff that we have discussed in the last lecture. So as this is a combined class for TC1, TC2 and TC3. So what we have done in the last lecture, we have discussed about the basic fundamentals of DC and that what actually that you are going to learn, okay, during this semester. So that course outcome, program outcome, basic topic or basic chapter name that we are going to discuss, that we have discussed already in the last lecture, as well as I will give you the evaluation and teaching pattern, that what you're supposed to submit, what type of the exam will be there, and what type of the stuff that you need to keep in mind to getting a good marks. Okay. One thing that I am going to clear with the online mode. So today I have get one report from this Cisco WebEx, and I have found out that there are several students are there who is joining in an initial lecture, and then after a few minutes, after 5 minutes or 10 minutes, they are going to left. Again, they will join at the end of the lecture. Again, it is going to left. So if I found that your like let's say there are 60 minutes of the lecture, and if I found that you are not available more than 50 minutes in that lecture, I'll consider your absent. Okay, because you are joining for 5 minutes, going to left. Again, you are joining for 5 minutes, again left. So there is a no meaning of attending this lecture. So please don't do such type of the things, because that people are joining frequently and they are not continuous during the lecture. So you arrange something where there are a good internet connection and you need to sit at the specific place. So do this stuff seriously. So what we are going to discuss in this lecture, this is a revision for TC1 and there's a new for TC2 and TC3. So within this week, we will come on the same pitch with all the classes. Then we will go with the new topic. Okay. So what we have discussed in our previous week with the TC1 class, which is regarding the type of signals. So there is a first lecture which is named as a signal characteristic. So with the signal characteristic, what are the different types of the signals? What are the meaning of those signals? How it will look like, and the basic characteristic we are going to discuss in this chapter. So topic that we are going to discuss in this first chapter or first unit, which is analog versus digital. periodic analog signal, digital signal, transmission, impairments, data rate limit, and performance. So these are the basic signal characteristic. Like whenever we say that there are signals, what are the types of signals, how it will look like, what is the basic characteristic of that? Okay, that all stuff we are going to see over here. So first it will start with the difference between data, information, and signals. So there are three different terms we have. Whenever we say data, whenever we say information, whenever we say signal, so these all are three different terms we have. So what is a data? Data is nothing but data is a raw, unorganized facts that need to be processed. Okay, like you can say you have put one meter on your roof. Okay, and that meter is measuring the temperature of your environment. Okay, so you have started that temperature sensor from morning, and from the next morning it is continuously sensing, and after every few minutes or few seconds of time it will send that data, into a specific cloud, or we can say specific web page or anywhere. Okay, so you are having a, like you are doing this experiment up to, let's take 1 month or 2 months or more than that. So we can say whatever the information you are getting from the temperature sensor, which is going to be considered as a data, which is raw. You have not got any particular information from that, like by measuring such large span of the information, large span of this data, what you are considering or what is your observation. So we can say whatever the things that you are getting from the temperature sensor is known as a data. Anything? Phone? Hello? Phone? Want to call someone? So whatever the things that you want to taking from any particular sensor, it's considered as a raw information. You have not processed it. But after getting all the data, now you are applying some algorithm that how much temperature, average temperature between 9 to 12, how much temperature between 1 to 3, how much temperature is going to vary from this first day to the last day. Now, if you are processing that data and you are getting some information from that, like from this Monday, Tuesday, Wednesday, Thursday of the first week, your temperature is higher, then it is going to be lower. In the morning, the temperature is lower, then it is going to higher, again it is going to very lower. So you are getting some information from that by processing that data. So data is considered as a raw, which is unprocessed, and there is just the readings, you can say. But when you process on that, when you put some algorithm on that, when you will put some range in that, whenever you're getting a meaning of them, then it's considered as the information. Okay, so readings or kind of the some of the, I can say, observation you are taking, it's considered as a data. But when you process it and when you are come to some outcome or come to some conclusion that based upon this data, this is the information I am getting. So this is a basic difference. One is unprocessed, another is a processed. Okay. Signal is nothing but it is presenting, we can say that's one particular way of presenting those information, or we can say that particular data. Like we can say I am having a data in 0101. There are a large string of the data is there, 00111, like several bits are there. Now to presenting that kind of the infinite sequence of that zeros and ones, which type of the signal you are using. Okay, like whether you are using kind of the two level system, four level system. What is two level, what is four level, we are going to see just after in a few minutes. Okay, but which type of the signal you are using, which type of the voltage you are giving to those zeros and ones. Either you are presenting in terms of bunch of data like 0001 1011, or you are presenting individually 010101. So how you are presenting those information, how you are presenting those data, that's considered as a signal. Okay, that some voltage characteristic you are adding into that. Okay, or some physical signal you are assigning to that. That's considered as a signals. Okay. So data can be both of the type of the data possible, analog and digital. Okay. So what is the analog and what is the digital? So there is a clear cut definition over here. Analog, it means continuous time, continuous value. Okay. What do you mean by continuous time, continuous value? Meaning of that, whenever you are measuring a value of your amplitude, it is going to vary continuously with respect to time. If I'm going to take an example of this analog signal, like you can say with this analog signal, you consider any point of time, their amplitude is going to differ. Okay. So over here, you can take over here sample or here sample or somewhere else sample. Whatever the amplitude of this signal is going to be differ every time. So if any signal which is having a continuous variation with respect to continuous time, that's considered as an analog signal. Their value is not fixed to any one particular level. It is changing continuously. So that's the analog signal. What is the characteristic of digital signal? Digital signal is a discrete time, discrete value. So you can identify that for a specific period of time, your value of their amplitude is constant. So like we can say for this particular period, your value like this one. For next particular time of period, your value is going to 0. Then another next particular period of time, your value is something higher amplitude. But for that duration, your amplitude is going to be constant. So we can say for discrete time interval, your value is also going to be constant. Discrete time, discrete value. And by looking to that signal, you can identify, like for this particular second, your signal is going to be fixed to that amplitude, stuck to that amplitude. So if such type of the signal you are observing, this is all considered as a digital signal. Okay. So there are two basic difference, analog and digital. That's the basic definition everybody should know. Now there are a different characteristic of this both of the signals, analog and digital. Okay. In analog, there are two type of the signal we have. So digital we are going to discuss afterwards. First we will start with the analog. So analog having a two type, periodic and non-periodic. Now what do you mean by periodic? What do you mean by non-periodic? So best example that everyone will take, that periodic is considered as a sine wave. Okay, so whenever you see the sine wave, you know that after some interval of time, your signal is going to be again repeated their value. Okay, so in sinusoidal way, you know, like after some period of time, same pattern is going to repeat it, and it is going to be repeated up to the infinite time period. So if such type of the signals you have, where a specific type of the signal or specific type of the amplitude variation is repeated again and again. If such type of the pattern you are observing, it is considered as a periodic signal. You can off this fan. Okay. So if such type of a thing is happened, like some specific period of time and that amplitude variation is repeated again in your kind of the entire time span, it's considered as a periodic. While non-periodic, it's just opposite. So such type of the no such periodicity you are observing. It is random. Like sometime it is going to be one cycle completed in 1 second. Another cycle is completed in 2 seconds. Then it is in a half second. So if such type of the periodicity you are not observing, that's considered as a non-periodic signal. Is it okay? Periodic signal and non-periodic signal. If signal having a periodicity, so it is having a specific kind of the property that you can define by looking to that signal. Obviously, non-periodic signal also having the same characteristic, but it is easy to observe some property in periodic signal by looking to their shape. Okay. So first property you can say there is a frequency. Okay. So how we can identify the frequency? Frequency going to be identified by the time period. Now what is a time period? Time period is nothing but the signal will complete their one cycle in how much time? Okay, so we can say if there is a sine wave is there, so starting from 0, it is going to high, then it is going to 0, low, and again it is getting repeated. So from starting to that repeated phase, how much time it will take to complete? Or we can say how much time it will take to complete a one cycle, that's considered as a periodic signal. Okay, and that time period is considered as your period of that cycle. So if you take a equation like that, f equal to 1 by t, so you are getting a frequency. Okay, so frequency also having a definition like that, in 1 second, how many cycles is going to complete it? Or we can say that to complete a one cycle, how much time it is taking. So both of are relative to identify the time period and frequency. So we can say that periodic signal can be also classified as a simple and composite. So what is a simple and what is a composite? Simple, it means only a one cycle, or we can say one signal is present. Like you can say sine wave of this amplitude. So there is only a one signal we have. While we can say composite signal is nothing but it is not a full slide. Hello? Okay.
No, sir.
No, sir.
Double single
Okay,
matter.
double screen. Just a second. Just a second. Is it okay now?
Yes, sir.
Yes, sir.
Okay. So you open your mic and tell me because I am observing something new. Okay. So these are the stuff we have. Like if we have a time period, from that time period by taking a 1 by t, you will getting a frequency. And if you have a frequency, by taking a 1 by f, you are taking a time period also. Okay. So how you can identify this both of these stuff? So there are one table is there. So we can say if one cycle, we can say that second. Yes. Any question? Yes, Ekta, any question? No? Okay. So we can say like if there are 1 second is taking to complete a one cycle. So 1 by 1 second, you can say there is a 1 hertz. So hertz is a unit of frequency and time period is always in second. So if it is taking a 10 raised to minus 3 seconds, so it will taking a 1 millisecond time to complete a one cycle. So their frequency going to be kilohertz. If it is going to take kind of the 1 nanosecond to complete that one cycle, so their frequency is gigahertz. So as you can see, your period to complete a one cycle, if it is going to reduce, your frequency going to increase. So that's both are in a opposite in nature, inversely proportional. Number of cycle is going to slower or it's going to be lesser to complete a one cycle in lesser time, frequency is going to higher. And number of cycle is taking a larger time, frequency going to lower. That's the relationship we have. So these are the example with the second property, which is the amplitude. So amplitude will be like how much strength in your signal. So we can say with the same signal, with the same frequency, this is a higher peak amplitude, this is a lower peak. It's nothing but like that. You can say whenever you just rotate your volume button in your tape recorder or volume button in your car, we can say that in your car music system. So you are nothing but you are increasing their amplitude because whatever the frequency, whatever the music you are hearing, it's a constant. So either you are playing with the lower amplitude or higher amplitude. So you are nothing but increasing their peak amplitude. So there is a second property, lower peak or higher. It's look very easy. Third we have, which is a stuff of like we can say period. So as I have told you, like frequency is a 12 hertz. Now what is the meaning of 12 hertz? Like 12 cycle is going to complete it in 1 second. Okay. So what is the time period to taking complete a one cycle? 1 by 12. Similarly, we can say there are a 6 cycle is going to complete it in 1 second. So there is a 6 hertz frequency. So how much time it will take for one cycle? 1 by 6. So that's the relationship between period and time that you can observe from this both of the diagram. Okay. So the power we use is at a home, which is having a 50 hertz frequency. So whatever the power supply board you are seeing at your home, it is having a 50 hertz of frequency. And at the 50 hertz of frequency, you are having a 50 times or 50 chance in a 1 second to just pull up your hand. Like whenever you feel a shock, कि जब भी आप कोई स्विच बोर्ड में ऐसे भूल से कोई आपको शॉक लगा तो 1 सेकंड में आपको 50 बार ऐसा टाइम मिलता है जब आप अपना हाथ खींच सकते हो. क्यों? क्योंकि 50 बार 50 times your signal is coming to 0 volt and at that time you don't feel a shock. But it in 1 second there are 50 cycles are there, so you are feeling like but that there are amplitude is there in which 50 times you have a chance to having a 0 volt and you can pull up your hand. Okay, so that's the thing we have. And if you have feel like Whenever you are just getting shock from such AC signal, your chance to get back, or your chance to just get detached from that switchboard is higher. But if you have touch with your car battery, okay, then definitely it will just end it when your body is getting punctured. Why? Because it's a DC voltage and there is a no frequency. There are a no time to coming to zero. But if you have touched your car battery, then definitely it will damage your body, and it will just let you go once your body is getting punctured. But in AC, it's not going to be happen. Why? Because there are a 50 times you have a chance to just pull up your handbrake. That's the reason. Okay. Third parameter, which is a phase. Phase, we can say how much advance or how much delay your signal is started. Okay. So over here we can say which is a 0 degree phase. It means it's a normal sine wave starting with the zero, going with high, coming to low, and so on. Okay. While we can say there are a 90-degree phase shift. So you know that one cycle complete, it means 360-degree rotation in your that all STC type of the circle is there, like sine, cosine, and also we can say at 360-degree rotation, your periodic signal again start with their initial value. So we can say if I'm saying that 90-degree phase difference, so your signal is starting from 1/4 of your time cycle. So as you can see, whatever the 0 degree signal is there, now there is a 1/4 time, we can say that advance, okay, in the generation. While we can say there are a 180-degree phase shift, then it is starting from zero, but that first cycle it is going with the negative amplitude. Why? Because it is a 180-degree advance in your signal. So this is a phase value, like how much phase advance you are making, 1/4 t or 1/2 t. So it's both of the way. Like this is a 90-degree advance, or we can say 270-degree delay. Either you are taking 90-degree advance or you are taking 270-degree delay. Both of the way we can present over here, either delay signal or advance signal. Any doubt till now? So anybody in online, anybody having any doubt, please ask me. Okay, chaliye, good one. Coming to the next, and that's a wavelength. Periodic and aperiodic signal under there is a wavelength. Now, wavelength is little bit of tricky. Okay, frequency you know, time period you know, amplitude you know, and phase difference you know. Now, wavelength, which is going to be a ratio of two different kind of the speed of light, or we can say two different speed of quantity. Like I can say when wavelength is going to be identified, wavelength is going to be identified with respect to what is your previous wavelength, or what is your, you can say, previous frequency, and what is your current frequency. Okay. If you can say you are launching some light, let's take there are some light you are just launching from one source, and you are launching that light into water. आप क्या कर रहे हो, लेजर बीम लेके आप वाटर में उसको कुछ ऐसा ऐसा लाइक यू आर गिविंग सम प्रोजेक्शन, और यू आर giving that light to any other body, glass, thick glass. Now what happened? You are launching a light from air, while the light entering to the another medium, either in a water or in a glass or any other medium. Okay. So whatever the wavelength in a free space, whatever the frequency in a free space, it is not going to same in that medium. Okay. So your speed of light might be going to be advanced, or it's going to be delayed. Okay. Either their frequency going to increase or their frequency going to be decrease. Now, whenever you are taking a ratio of your such wavelength at particular medium, okay, that ratio consider as your wavelength. Okay. So if we can say right now I'm launching the light at this particular second. Okay. After 1 second, light is traveled to that much distance, just for example. Now, what is a medium? Medium is still air. So I can say there is no change in the wavelength. So that ratio is going to be common. So we can say, like, what is the wavelength over here right now? You are taking with reference to speed of light c and divided by the frequency f that you have given to that signal. So let's take you are having a laser light is there and having a frequency of 120 terahertz. So after a few seconds of time, still that same thing it is in a air only. So that ratio will be C by F, and lambda you are getting with respect to that one. So lambda, which is nothing but the wavelength, and identify with respect to C by F. And how you can get F? By the time period. So what is the time period of your frequency right now? What is the time period to complete a one cycle? With respect to that, you are getting a frequency. From that frequency, you getting the wavelength. Okay, and that is the reason, or that is the ratio. Okay, like if you are identifying a frequency, and if someone will tell you, yes, there have some student has passed something. Uh, Sir, then wavelength is changing, but frequency is not changed because wavelength is characteristic of median, frequency is characteristic of origin. If you consider at any specific medium, both going to be changed. Arshil Kumar, both going to be changed. Why? Because both are relative to each other. Okay, F equal to C by lambda. So speed of light going to constant. Okay, whatever your time period going to change to complete one cycle, your frequency change, and if frequency change, their wavelength is also going to be changed. If you have taken an example of any prism, and when you launching the, like this example already you have studied in a 12th science. If you launch a white light from one side, in output side, there are 7 lights that entire spectrum is going to gain. Why? Because in white light, there are a combination of all the light which is traveling together with equal phase. But when it is entered to one prism, what happened? Their wavelength is going to differ. That's why some light is going to coming at different angles, some light is going to another angle, and all you can observe at the a different kind of the angle with the different side of the lights. Okay, so both are related. It's
Okay,
not
okay,
like
sir.
so both, it will not like that frequency going to constant and wavelength change. Wavelength change, frequency because it's relative, like 1 by lambda, f equal to 1 by lambda, lambda equal to 1 by f. Okay, so both are going to be relative with each other. But if somebody will ask you what is a relationship between a frequency and wavelength, so you should be answerable like f equal to c by lambda. And what is a very good thing behind this particular thing? Like c, how we have find out that there are a speed of light is equal to 3 into 10 raised to 8. हमको कैसे पता चला कि भाई speed, light of speed is going to 3 into 10 raised to 8 meter per second. So that Einstein and other scientists from thousands here, they are giving a different calculation. Like एक लाइट को यहाँ तक पहुंचने के लिए इतने मीटर पर सेकंड का टाइम लगता है. Like there are several kind of the calculation they have done, as well as they have like there are in our Indian kind of the Veds and Purans, and we can say near to the Hanuman Chalisa also, that everywhere they are mentioning that speed of light is going to be 3 into 10. So there are some roots are there about the speed of light, and people are doing lots of experiment since thousands of years. Then they have come to this value, that their value is speed of light is 3 into 10 raised to 8. Okay, so imagine like that. Right now it is very easy to understand for us that speed of light is 3 into 10 raised to 8. But how it will came? Similarly, we are having a story of numbers like that. Whatever the number you are saying, 1, 2, 3, 4. But why there is a 2 is always 2 like this one, not something else? Why 3 will be written like 3 only, not something else? So to getting this number 1, 2, 3, 4 and all the stuff, there are thousands of years of Greeks, this mathematician, they are having a lots of number system from lots of images and all the stuff. There are some standard 10 digit as fixed, which is easiest to understand and which is make a total revolution in terms of calculation, in terms of I can say mathematics and all the stuff. Okay. Right now, there are also some of the unsolved mysteries are there with respect to complex number. Can you see the complex? How you can say the complex number is available? I can say 1. Whenever you say x square plus 1 equal to 0, I think there is the same example you have studied many times. X square plus 1 equal to 0. So x is a complex number. Everybody is agree with that. So how you can see complex number? If I can say x square equal to 1, then you know that under root of 1, you can get it as a x. But x square equal to minus 1. So how you can see that number, that minus 1? So whenever you can say, whenever you are having an x square, so how that graph will be look like? How the graph of x square equal to 1 will be look like? Whenever you can say x equal to 0, your output is going to 1. Whenever you are having x equal to 0, output is going to be 1. So we can say there are from infinite period it will came, it will stop to 1 and again it will go to infinite. So there are no graphics touching to that one particular 0. That's the normal number. But above the complex number x square equal to -1, -1 is a downside. So you cannot see that graph observed in with your real life. There are an imaginary part you are seeing from that, we can say regular arithmetic operation. Like if there are a regular two axis number, you can say this is a x axis, this is a y axis. But where is the complex axis? There are no complex axis in a real life. Okay. And scientists are also saying like that all the real numbers actually are made up of complex number. If you say 1, it's not a 1, it's 1 plus 0 I. When you say 2, it's not 2, it's a 2 plus 0 I. There are no complex number, that's why it's considered as a real number. So there are a big discussion in that one, and how the complex number came and what are the problems that people are facing. There are hundreds of years of that people are identifying for the solution, that how I can present x square equal to -1. So that's the big discovery. It's looked very easy, like mathematics my professor ne bol diya, like under root of -1 it's considered as I. How I came. Okay, so just think about that. So sir, means first complex number. No, first is a real number, second is a complex. Now, if I say I am having a 5, so it's considered like that 5 plus 0 I have. So complex part is 0, real part is available. So we can say every number should be present like this one. But for easy to understand, whenever there are a complex number is not with us, we will just skip in terms of presenting that. So that's just a mathematical discussion, and I'm not a proper faculty for that. I think you can discuss with DMGT faculty. But this is just an example that I want to share with you. So now there are important thing over here. Okay. How you can say, just a second. Any links? So from the TC3 group, I think not having anyone having that link of that class. Is it like that? Is there someone from TC2 or TC3 class over here? I'm talking about online. Does anyone is from TC1 or TC2 class? Sorry, TC2 and TC3 class.
Yes, sir. TC2 class.
So are you having that link in Telegram or? So can you share this this lecture link to there in a Telegram, because I have forgot to share it today, and I have sent you already the mail. So I don't know that why there are such question is there that they are not able to join the class. I don't
सर
know.
TC2 वाले टेलीग्राम में नहीं है.
TC3 वाले तो है ना? TC3 वालों का तो लेक्चर का लिंक मैंने मेल ही किया था ना सबको.
यस सर.
मेल
सर वो कैलेंडर में आ गया.
हाँ, कैलेंडर में सबको है ना. तो फिर क्यों ऐसा क्वेरी है कि भाई लेक्चर नहीं टेलीग्राम में ज्वाइन करो. 1 मिनट, हाँ मैं भेज देता हूँ अगर किसी को प्रॉब्लम. I have added in already in calendar. So those who are in online, make sure you will add this link in your calendar so it is easy to join. Okay. So next topic that we are going to discuss, which is a time domain and frequency domain. Okay. So whatever the real life signal that you are observing, like there are one wave is going, I think wave itself we cannot observe, but there are something which is going to travel through any specific period of time, like some sound is generated at one particular distance, and after a few seconds of time you can see at your place. So you can consider like that sound is traveled from there and coming over here. So there are a time domain analysis you have done with that you are observing in a time. Okay. So whenever you are saying that you are putting your axis, you are putting your axis as a time domain, and you are identifying how much amplitude is vary with respect to that time. So that's a time domain representation. So first type of the signal already you know that how to present a sine signal. So easily you can do like that. But how to present a frequency domain signal? That's the new for you. So what is a frequency domain signal representation? It will be like in your one axis, you have a frequency. Okay. While in another axis, you have amplitude. So if you are having a frequency axis, so as the time axis, you will starting with time equal to 0, 1 second, 2 second, 3, 4, 5, 6, 7. Likewise, the second you are putting. So what we need to put in frequency? 0 frequency, 1, 2, 3, 4, and frequency it is in hertz. So 1 hertz, 2 hertz, 10 hertz, 20, 200, 1000. So likewise, there are hertz are there. So simply when you are saying presenting a frequency domain signal, simply what you need to do, whenever your frequency point will came, like in time domain, you have found that this sinusoidal wave having a 6 hertz frequency. So simply you need to put one straight line at a 6 hertz point in the frequency domain. Are you getting my point? So in time domain, it is starting from 0, 1, 2, 3, 4, 5 seconds. Likewise, in frequency, it is starting with 0 hertz, 1 hertz, 2 hertz, 3, 4, 5, 6, like that. So if you have found in your time domain, your frequency is a 6 hertz. So simply in a frequency domain, what you need to write? Just one particular spike. That's the way of representing time domain and frequency domain. Okay. And this is a two window. If you can say there are two signal is getting composited. Now, what do you mean by composition? Like there are two signals are there, one with the one frequency, another with another frequency. Both are periodic, दोनों sine wave है, दोनों periodic है, okay. But your final output signal is a combination of both of them. So I can say the first signal will be look like this. I can say this I can say violet color. Another is going to be green. So their composite is nothing but summation of this both of them or multiplication of both of them. So ये दोनों का जो भी amplitude का multiplication होगा, whatever the amplitude multiplication of this both of the signal, consider as a this signal, composite signal. So in this signal, which is considered as a periodic, having a two frequency component, first this one and second this one. So how the frequency domain representation of this one spike at this green frequency, another spike at this violet frequency. So you can say if this is a frequency of this signal will be 10 hertz, over here it's a 20 hertz. So you have a two spike for such type of the signal, you have a two spike, one at a 20, another at a 10.
सर
Yes, please.
सर अगर सिर्फ एम्पलीट्यूड डिफरेंट हो लेकिन फ्रीक्वेंसी सेम हो तो
Then you
कैसे
can
रिप्रेजेंट करेंगे?
amplitude is different and frequency same. So there are overlapping spikes are there. Like यहाँ पे, like you can say there is a one spike, green spike up to 10 volt, and another higher spike at the 20 volt, 20 volt. Okay. And composite signal is nothing but how it will look like the composite signal. It's overall 20 volt higher signal. So if amplitude is going to common, amplitude is higher, but frequency same, so overlapping spike are there. तो एक स्पाइक आएगा 10 वोल्ट का, दूसरा स्पाइक आएगा 20 वोल्ट का, बट उसी फ्रीक्वेंसी पे. ठीक है, दो अलग अलग एम्पलीट्यूड, अलग अलग फ्रीक्वेंसी, सो अलग अलग सेपरेट प्रेजेंट. यस यस, स्पीक अप.
गॉट इट सर.
Got it? Yes. So with this example, you will get the idea that one amplitude, like there is a 15 amplitude. So how the signal will look like? What is the name of the signal having a 15 straight line? DC signal. So we can say there is a no frequency straight line. So 15 amplitude DC signal having a no frequency. No frequency, it means spike at 0. Okay. Another amplitude signal, which is this is a pink signal, having a frequency of 8 hertz. Like it will complete an 8 cycle in 1 second. So I can say there is an 8 hertz frequency with the amplitude of 10 volt. So at 10 volt, one spike at a 8 hertz frequency. Likewise, another green signal having a 16 cycle is completed in 1 cycle. So we can say that frequency is a 16 hertz, amplitude is a 5. So it will be like this one, 16 hertz frequency, amplitude at a 5 volt. Any doubt in this one? Anybody? Any doubt in this one? Simple. So we can say like that, periodic signal and especially periodic composite signal, like एक साथ multiple signals आपके periodic pattern में है. So you can say there are 3 signals combined, 15 volt, 10 volt with 8 hertz frequencies, 5 volt with 16 hertz frequency. So periodic composite signal having a frequency domain as a scattered lines are there. अगर आपके पास ऐसा सिग्नल है जिसमें पीरियोडिक सिग्नल है अलग अलग एम्पलीट्यूड के, तो उसका फ्रीक्वेंसी डोमेन कैसा होगा? ऐसे स्पाइक्स वाला. सो यू कैन से देयर आर discrete frequency value are there for such periodic analog signals. So the stuff is representing over here that let's say you are having a periodic signal, so that period is going to define like ये पूरी cycle के बाद ये same cycle repeat हो रही है, but it does not look like a sine wave. It does not look like a sine wave. So this signal is made up from several frequencies. Like कोई frequency हो सकती है 15 volt की with the DC signal, some frequency with the 8 hertz with some 10 volt, then 16 hertz with 5 volt. Another signal is there, but all are periodic. And if you all combine it in if you are all combining with them and representing a one signal, so that signal is also become periodic. So periodic signal को combine करने पे आउटपुट भी पीरियोडिक मिलेगा, बट उसका शेप चेंज हो जाएगा क्योंकि हर एक का एम्पलीट्यूड अलग अलग है, हर एक की फ्रीक्वेंसी अलग अलग है. सो वी कैन से दैट कंपोजिट सिग्नल ऑफ सच पीरियोडिक एनालॉग, their amplitude or we can say their frequency response is look like a discrete. Okay, so here there is an example of such signal, like with the composite signal is periodic, decomposition of it gives a signal with the discrete frequencies. If the signal is non-periodic, then decomposition of that combination will give the continuous frequency. Now, what is the meaning of that? That we will understand later. But by looking to this diagram, now you are very aware about that. Analog signal है, periodic है, चाहे अलग-अलग amplitude हो, but if signal is periodic with different amplitude, their frequency response is a discrete. Discrete spikes are there. अलग अलग जगह पे अलग अलग spike होगी. क्यों? क्योंकि by looking to this periodic signal you can identify कि भाई इसके अंदर ये F frequency 9 volt की होगी, like 3F frequency 3 volt की होगी, 9F frequency 1 volt की. So you can decompose it easily. So if it is decomposition with discrete value, so that frequency values also get discrete. But if the signal will look like this one, so this signal is a non-periodic signal. You cannot identify any frequency. You cannot identify any period. Amplitude is also going to differ. So if a composite signal made up as a non-periodic signal, having a not any particular frequency you can identify from that, so their frequency response become a discrete. This frequency response become continuous. क्यों? क्योंकि आपको पता ही नहीं है कि ये फ्रीक्वेंसी और ये फ्रीक्वेंसी के बीच में एग्जैक्ट कौन सी फ्रीक्वेंसी होगी. All frequency are coming together for such signal. जैसे कि मैं आपको बोलूं कि like right now I am speaking. So what is a human frequency? It is a 20 to 20 kilohertz. Now it is not fixed like कि मैं 15 hertz पे बोल रहा हूँ, 15 kilohertz पे बोल रहा हूँ, 12 kilohertz पे बोल रहा हूँ. No, it is not fixed. Depend on which type of the I can say vocal or which type of the word I am using. According to that, that frequency is something different. So whenever you analyze a speech signal, so उसका एक रेंज होता है कि भाई ह्यूमन 20 किलोहर्ट्ज से ज्यादा नहीं बोल सकता. Human can speak up to 20 kilohertz. So you know that starting is a 20 hertz, ending is a 20 kilohertz. 20 hertz से 20 kilohertz के बीच में ये बंदा बोलेगा. But कौन सी frequency बोलेगा? You don't know. So you need to put a continuous presentation of that frequency domain. Like between this to this, human can speak any frequency. So my voice is considered as a non-periodic signal. Okay. And with that non-periodic composite signal, their frequency domain is going to continuous. It is not such type of the discrete, because you cannot predict any frequency from that sound. So that's why you should give the continuous one. Any doubt in this one? Any doubt? Any question? No doubt. Everything is clear with everyone. Great. So these are the stuff we have, like periodic signal, non-periodic signal, frequency domain of periodic signal, frequency domain of non-periodic signal. So if we look two comparative diagram for the analog signal, like bandwidth with periodic signal, that will be considered is going to be like this one, having a discrete value, because you can understand there are a discrete frequency component. But bandwidth with the non-periodic composite signal, it is look like the continuous. So both having a same bandwidth. Over here it's a 4000 hertz. Yes, doubt. Boliye Darshan. Doubt? Darshan, speak up. What is the doubt? Darshan, you have written doubt in a chat box. Please tell me. What is a doubt? Okay, no doubt. So there are some, what is a propagation speed? Oh, so I have forgot to take this question. Okay. What is a propagation? What is a propagation speed? Propagation speed is nothing but, Darshan, like how much time it will take to complete that one particular cycle. That's, we can say, propagation speed. When you say speed of light, that propagation speed is a 3 into 10 raised to 8 meter per second. It means your light is traveled in 1 second. We can say in 1 second, your light is traveled to 3 into 10 raised to 8 meter. So that meter per second is the propagation speed of your that particular light. Okay. So in 1 second, how much distance it will cover or how much far distance it can go. Okay. That's considered as a propagation speed of any signal. Okay, it's meter per second. Yes. So these are the stuff we have whenever we can say there is a bandwidth of periodic and non-periodic. Bandwidth is nothing but, over here one new term, bandwidth. Bandwidth is nothing but what is your higher frequency available in that signal, what is a lower frequency available in signal. हायर कौन सी फ्रीक्वेंसी है, लोअर फ्रीक्वेंसी कौन सी है, दोनों का डिफरेंस करो. Like 5000 minus 1000, your bandwidth is going to be a 4000 hertz. So we can say there are 4 kilohertz. So bandwidth is going to constant, but frequency response is discrete in a periodic signal, continuous in a composite signal. Is it okay? चलिए आगे बढ़ते हैं. Next we have, मुझे लगता है लाइक अभी आप खत्म कर दोगे, क्योंकि अभी नेक्स्ट वीक से, नेक्स्ट लेक्चर से तो मुझे नई सिस्टम में जाना. ओके, तो चलिए, as everybody is just pop up very quickly, so we'll go with that second period lecture also. So now analog signal over. Two type of the analog signal, periodic, non-periodic. दोनों के frequency domain देख लिए. Now we have a digital signal. So what is the meaning of digital signal? Huh? Non-continuous, or we can say in another manner, discrete time, discrete value. You can identify that with respect to specific period of time, your amplitude is become constant. So we can say for this amplitude, this particular period, discrete time, discrete value. So for this particular period, your amplitude is constant to 1, or at one particular voltage level. Then after also it is same. For specific period time, that amplitude same. Likewise, this is also considered as a digital signal. Okay, so both are digital signal as it is coming to that digital signal definition. But what is the difference between these two digital signal? First digital signal is a 2-level digital system, while another, it is a 4-level digital system. Now, what is a 2-level? What is a 4-level? Okay, 2-level voltage system, you can say there are only 2 voltage are there, zeros and 1. Okay, now how we have decided this only 2 voltage level? By looking to presenting a number of bit at specific period of time. If you decide that in a specific period of time, you are presenting only 1 bit. So we can say only 2 possibilities are there, either 0 or 1. So 0 present with one level, 1 present with another level. That's a simple. If you have decided like that, in specific period of time, I am presenting a two digital data, 2 beats per that particular time period. So if I am presenting a 2 beat in one specific time period, so how many possibilities are there with that 2 beat? Like if I'm having a two binary bit 0 0, so how many possibilities are there? 0 0 0 1 1 0 1 1. So I'm having a meaning like that. I need to give a different voltage level for 0 0, for 0 1, 1 0 and 1 1. So if I'm presenting a 2 beat at a time, so I need to give, so it is not sufficient 2 voltage level to present. I must need to increase to 4. So when you are presenting a 2 beat at a time, at the time you require a 4 level. There is one question is there in a chat box. So question is there, can it be more than 4 level? Yes. You are presenting, let's take 8 digital signal, we can say 8 digital data in one specific period of time. आप 8 बीट एक साथ रिप्रेजेंट कर रहे हो, so you need to use a 256 voltage level system. So it is possible, like, but now what is the issue? You can say, if you want to present such type 1 and 0, it is very easy to generate. Like आप एक कंपैरेटर रखो, 1 आ रहा है तो वोल्टेज ये रखो, 0 है तो ये करो. You are putting simple a NOT gate, or you are putting a simple one transistor. If 0, 1 came, 1, 0 came. Directly 1 0 1 0 1 0 voltage you create. If you are having such type of the 4 level voltage system, so to create a such type of the voltage level, it is become difficult. Even if you are going with the higher number of system, 8 voltage level, 16 voltage level, 32 voltage level, you need to put a complex signal generator circuit with that. Okay, so there are a 6P, NQ, NRZ, there are a biphase Manchester, there are several line coding techniques are there, which will present simultaneously 3 beat or 4 beat with specific period of time. But you need to decide, like 4 signal, 4 beat में एक साथ represent कर रहा हूँ, if I'm presenting a 4 beat at a time, so how the rest of the 15 beat I need to justify. Okay, so for that you need to put a complex circuit. So यहाँ पे आपका beat sequence तो आ रहा है, but output में आपको ऐसे 16 voltage level signal generate करने के लिए आपको circuitry उसके लिए put करनी पड़ेगी. So there are another question we have. What is the use of the level more than 2 if it is complex? Consider like that right now, what is the speed of this one level system? Your speed is 8 beat per second. अगर आप 2 voltage level system use कर रहे हो तो आप कितनी beat per second जा सकते हो? 8 beat per second. But if you have increased to 2 beats simultaneously, so your speed is increased from 8 to 16. Okay, so if such type of the requirement is there, your beat per second, like your band is constant, like आप इसी बैंड पे यही फ्रीक्वेंसी पे काम कर रहे हो, बट आपको फास्टर डेटा भेजना है, तो क्या करना पड़ेगा आपको? You need to increase the voltage level. So previously whatever the beat per second rate is 8, by changing this voltage level it is increased to 16. So data rate is going to become a double with the same system. So same system में अगर आपको data higher and higher multiply करना है, you can. So two things we have. Either you making your channel broader to do the high speed communication, or you put your inside system such a manner that with that limited resource you can do the higher speed communication. So आप अपनी systems को improve करो higher speed के लिए, या फिर bandwidth ज़्यादा use करो higher speed के लिए. Both are going to be possible, depend on the nature, what is the requirement is there. Am I given your answer, Dhiren? Yes. So this is the stuff, like if you want to increase your speed, the same bandwidth, you can do the multi-level system. It is like our internet speed, like it is depend on that, like Ravi, whenever you say like whenever you are browsing, let's take something on YouTube. Okay, so whenever you are browsing something on YouTube, so whatever the layer architectures are there, with respect to that architecture, by using which particular communication you are browsing your your internet. Like if you are browsing it through the Bluetooth, you are browsing your internet through the any I can say LAN cable, you are browsing it through the Wi-Fi, you are browsing it through the another medium, depend on that your speed is going to vary. अगर आप ब्लूटूथ से इंटरनेट एक्सेस कर रहे हो तो ब्लूटूथ का जितना मैक्सिमम कैपेसिटी है उससे ज्यादा आप कितना भी हाई स्पीड का इंटरनेट लगा लो, आप उससे ज्यादा ब्राउज नहीं कर सकते. अगर आपके घर पे राउटर 150 Mbps का है तो आप उसके साथ 1 Gbps की लिंक लगाओ, आपको 150 Mbps के ज्यादा नेट आपको मिलेगा ही नहीं। तो इसका मतलब ये लाइक इट इज नॉट अ मीनिंग लाइक दैट यूट्यूब वाले 150 Mbps पे ट्रांसमिट कर रहे हैं, नहीं, वो तो 10 Gbps पे ट्रांसफर कर रहे हैं, बट आपका राउटर 150 Mbps का है तो आप 150 Mbps पे ब्राउज कर पाओगे। If you can say you are using mobile phone, so in mobile phone you are having a Wi-Fi chip, so that Wi-Fi chip never go beyond the 200 Mbps। अभी आप घर पे 400 Mbps का प्लान लगाओ, चलेगा ही नहीं, क्यों? क्योंकि आपके मोबाइल पे ही 200 Mbps लास्ट लिमिट है। So rather than to do that 200 Mbps, they are using one specific signal system। ओके तो वो एक स्पेसिफिक सिग्नलिंग टेक्निक यूज कर रहा होगा वोल्टेज लेवल का। अभी आप उसको मैक्सिमम लेके जा रहे हो, इट विल डू विद दैट वन, बट उससे ज्यादा कर रहे हो तो आप 200 का ही यूज कर सकते हो। ओके, एंड दिस वोल्टेज लेवल सिस्टम इज डिफर एज आई हैव टोल्ड यू विद रिस्पेक्ट टू हाउ यू आर कम्युनिकेटिंग। अगर आप ब्लूटूथ से कर रहे हो तो उसके लिए अलग सिग्नलिंग सिस्टम होगी जिसमें 4 लेवल सिस्टम यूज होती है। आप वाईफाई से यूज कर रहे हो तो उसके लिए 8 लेवल सिस्टम होगी। Okay, दूसरा कोई यूज कर उसके लिए 2 level system। So depend on the which type of the communication, depend on their standard, they are using a different voltage this level system। और उसमें भी वर्जन होता है like Wi-Fi 4.0, Bluetooth 4.0, Bluetooth 3.0। So with that version also this voltage level is also going to vary। like अगर आपके पास Bluetooth 3.0 का चिप है तो वो जो voltage level define किया होगा standard, उसी से आप communicate करोगे। So it is depend upon that which type of the communication media you are using and which type of the device you are connecting and what is the maximum speed of that device to access। Okay, that's the overall stuff। like मेरा इंटरनेट बहुत स्लो चल रहा है तो आपके डिवाइस में तकलीफ है, ठीक है, आपने प्लान बड़ा नहीं करवाया है तो ना वो तो अच्छे से उसके पास तो like if you have seen the server of Facebook or any YouTube, like there are like half kilometer or kilometer, like there are a wide warehouse are there where they are having a thousands or millions of servers are there, they are working on several Gbps speed। okay, like they are having a many cooling devices। you can see there are all the such YouTube or their servers are there, it is situated in Antarctica क्योंकि वहां पे ठंडी रहती है तो वो सब कूलिंग करने के लिए अच्छा रहता है। सो जस्ट सी दैट हाउ फेसबुक वर्क, हाउ व्हाट इज द इनसाइड ऑफ फेसबुक डेटा सेंटर, यू गेट अमेज। लाइक हर एक सेकंड में, लाइक हर एक मिनट में बहुत सारे सर्वर ब्लास्ट, लाइक यू कैन से फॉल्टी हो रहे हैं, उसके लिए वो एक स्पेसिफिक टीम ऑफ इंजीनियर्स आर देयर, they are continuously replacing those servers, those switches and all the stuff, and they are very high speed like a super computer। like itna chota, what do you mean by super computer, you can say like it is having 128 GB of RAM, 256 GB of RAM। so with respect to the 256 GB of RAM, एक रेक होता है इतना छोटा सा, और वो इतने हजारों लाखों ऐसे रैक्स है, उसमें हर वक्त आपका डेटा स्टोर हो रहा है, कम्युनिकेशन हो रहा है, like this। just see, you will get amazed with that how it's going। yeah, so this is about to end over here। everybody just write your enrollment number and name, and in the next lecture we will discuss with rest of the things। okay, so everyone just write their enrollment number and name and then they can go with the TC1 in offline। I'm taking attendance with TC1। TC1 last 2 digit 166 171 157 only 57 057 021 066। anyone from TC1? TC2 190 only 32 132 105 094 133। anyone from TC2? TC3 020 011। done? chaliye, it's okay, it's done over here। after writing your enrollment number and name, you can go।